Hello students, our today topic is transformer, and often question arises that what is transformer, explain principle, construction, working and theory of transformer, and how current is affected in transformer, and what are the various energy losses in a transformer, and what are the various uses of transformer, how can it is possible for long distance transmission easy for electric power. Okay, now first of all, what is transformer? Actually, transformer is an electric device for converting and alternating current at low voltage to high voltage or high voltage to low voltage. Clear? Or vice versa. If it increases the input voltage, it is called step up transformer, and if it decreases the input voltage, then it is called step down transformer. And first of all, what is the principle of transformer? It works on the principle of mutual induction, that is, when a changing current is passed through one of the two inductively coupled coils, an induced EMF is set up in the other coil. Clear? If changing current passing through one coil, then an induced EMF is set up in its neighboring coupled coil. Okay, now it is clear from the diagram. Now this is laminated core and this is turns NP for this is primary coil and this is secondary coil. NP number of turns of primary coil and NS are the number of coils of the secondary coils. Okay, the primary is connected with AC supply and the output of the secondary goes to the outer load. Okay, for step down transformer, NP should be greater than NS or NS should be less than NP. And for step down transformer, the number of turns in the secondary coil should be greater than the number of turns in the primary coil. Okay, actually transformer is of two types. One is core type. In core type transformer, the primary and the secondary coils are bound on separate limbs of the core, so that the core is largely surrounded by the coils. Many of the modern transformer are closed core type as shown in the diagram. And second one is shell type. In shell type transformer, the primary and secondary are bound on the one over another on the same limb of the iron core. The coils are very largely surrounded by iron core. The transformers used in radio and TV transmitters are of shell type transformer. Okay, now what is the working of transformer? How it works? As the alternating current flows through the primary, it generates an alternating magnetic flux in the core, which also passes through the secondary. The changing flux set up an induced EMF in the secondary coil. If there is no leakage, the flux linked with each turn of the primary will be equal to the linked with the secondary. Okay, now according to Faraday's law, we get induced EMF in the primary coil is NP d phi upon dt, and in the secondary coil it is NS d phi upon dt, and by dividing these two we get ES upon EP equal to NS upon NP. And in step up transformer, NS should be larger than NP, greater than NP, so ES becomes greater than EP. And in step down transformer, NS is less than NP and ES becomes less than EP. Clear? And input power always equal to output power, so EP into IP should be equal to ES into IS. Okay, now what about losses? The main cause of energy loss in the transformer are: number one is copper loss. Due to heating of the copper wires, used in primary and secondary coils in the binding. The power loss is I square R. It can be minimized by using thick copper wires of low resistance. Okay. Now second loss is eddy current loss. The alternating magnetic flux induced eddy currents in the iron core, and this which leads to some energy loss in the form of heat, and this loss, eddy loss, can be minimized by using laminated iron cores. Okay, third one loss is hysteresis loss, and the alternating current carries the iron core through cycles of magnetization and demagnetization. Due to demagnetization and magnetization, the hysteresis loss occurs, and this can be minimized by narrow core, soft iron core, which can be minimize the hysteresis loss. And fourth loss is flux leakage. Magnetic flux produced by primary may not fully pass through the secondary. Some flux leaked during the whole process. Okay, and this can be minimized by binding the primary and secondary coil over one another like this. Okay, now fifth loss is humming loss. As the transformer work, the core lengthens and shortens during each cycle of alternating voltage due to phenomena of magnetostrictions. This gives rise to humming loss. So some of the electric energy lost in the form of humming sound. Okay, these are the losses in the transformer, and transformer is used in radio receivers, telephones, TV, refrigerators, in stabilizers, okay, and electric building. Even step-up transformer is used in production of X-rays. In transmission of electric energy, mainly transformer is used. The most important application of transformer is in the transmission of electric power from a power station to far away areas where it is actually used. It minimizes the power loss during the transmission of the electric power. And clear? And it is all about transformer, step up transformer, step down transformer, types of transformer, and losses of the transformer. Thank you.